The chaos theory.
Chaos theory is defined as the science of how things change, how certain events in time can affect other events in the future. Most think of chaos as a mess. It is self-contradictory, disorganized, and the state of chaos is paradoxical. However, the simplest way scientists have been able to put the chaos theory into words is by calling it deterministic unpredictability. The definition of deterministic is that the future can be determined by the current state of the present based on laws of nature. Scientists for years have been studying the orderly, the repetitive, and the unpredictable, but they had steered clear of the unknown, the unconventional, and the chaotic. The chaos theory is a field of scientific study in mathematics that is applied in a myriad of different topics such as physics, engineering, economics, biology, and philosophy.
One of the earliest pioneers of the chaos theory was a man named Edward Lorenz. While in the midst of conducting simulations of artificial weather, the chaotic appearance of the different weather patterns sparked an interest in him. He was able to determine that weather is only predictable about a week in advance, and then after that, the pattern was undeterminable. He discovered that even the simplest events could cause the most complex behaviors. He called this idea sensitive dependence on initial conditions. One of the reasons why chaos is revolutionary is because it emphasizes a different side of nature than usual. It allows you to break down even the most complex behaviors into simple parts in order to determine the answers. Once figured out in small pieces, the complicated puzzle can then be put back together and solved much easier. There are often times where the interactions of the individual breakups can combine to more than one original whole.
There have been many concepts that have sprouted from the idea of chaos and the theory behind it. One of those concepts that is well known by scientists around the world is the butterfly effect. The butterfly effect was first presented as a simple question asked by Edward Lorenz in 1972 when he gave a lecture at a conference. It was asked, can the flap of a butterfly's wings in Brazil start a tornado in Texas? This question sparked ideas in many young scientists' minds, and they were able to determine that, indirectly, yes, a butterfly in Brazil could begin a tornado in Texas.
Even though they are complete opposites, order and chaos go hand in hand. Many consider chaos to be its own form of order, a form of order that is unexpected and undetermined, but nonetheless one that appears often but not in the same way each time. When Lorenz was performing his weather simulations, he would find that in his calculations that were supposed to repeat in the same pattern would sometimes encounter what he called an iteration. An iteration is like an error. In this case, it was an error in a set of numbers. Even if the error only affects 0.1% in a rational number, it can make a difference. In the beginning, the error seems minor and is barely even noticeable. However, as the rational number continues to go through the pattern in the rest of the sequence, instead of the original predicted number, you arrive at a number that has a much more significant error than when you began the process. A theory applied in various branches of science that apparently random phenomena have underlying order. The chaos theory.